You can spend months running empathy interviews, perfectly mapping your customers' pain points and polishing your design. But when that new product finally hits the market, it's probably still going to fail. This extreme uncertainty is why Silicon Valley adopted the mantra, fail fast, fail often. But if you yell that in a traditional manufacturing company where people are trained for zero defects, you'll trigger a panic attack. To them, mistakes are a sin, and that culture clash creates a dangerous misunderstanding. Employees hear fail fast and think leadership is giving them permission to do sloppy, careless work. If the boss says it's okay to fail, why bother sweating the details? Success depends on a different metric. The companies that survive simply fail faster, they fail cheaper, and they fail much smarter than their competitors. To do that, you have to drop the ego.
You stop running your business based on gut feelings or blind belief, and you adopt the cold logic of the scientific method. You run systematic tests. You stop hoping to be right on the first try, and instead engineer intelligent failure. You use small, deliberate failures as a tool to map out exactly what the market will actually pay for. When you treat your business like a lab, the very first step is establishing a falsifiable hypothesis. You need a specific statement about your customers that you can test, measure, and, crucially, prove wrong. Let's look at a real-world scenario. A B2B construction materials supplier wants to digitize. The executive team plans to spend 2 million baht and 6 months of development time to build a full-scale e-commerce platform for heavy materials. Before signing that 2 million baht check, they identify their riskiest assumption. The entire project rests on a single, unproven belief that modern contractors are actually willing to order massive shipments of cement and steel by tapping a checkout button on their smartphones. This brings us to step 2 of experiment-based learning, defining your affordable loss. Instead of risking the company's annual budget, they set a strict limit on the blast radius. They cap their exposure at 10,000 baht and 3 days of work. They don't write a single line of complex code. In 3 days, they build a dummy landing page with a fake add to cart button. When clicked, it asks for a phone number so a sales rep can call them back. They spend that 10,000 baht running targeted ads to contractors. By strictly applying the affordable loss rule, the executives took a massive financial risk that could have tanked the quarter and shrank it into a cheap, isolated exercise in gathering raw data. Now they move to step 3, measuring the results using actionable metrics. They ignore vanity numbers like how many people clicked like on the ad and look strictly at the conversion rate, the people who actually tried to buy. The results are brutal. Out of 100,000 people who saw the ad, only 3 contractors actually left their contact information. By any traditional standard, the landing page was a total flop. But here is where step 4 kicks in. Extracting validated learning. The team conducts an after-action review, calling those 3 leads to find out exactly why no one else was buying. The phone calls reveal a massive blind spot. Because steel and cement prices fluctuate daily, contractors refuse to put massive orders on a credit card. They require 60-day credit terms, and they need a human being on the phone to negotiate the daily rate. For the price of a few ads and 3 days of effort, the company identified a fundamental flaw in their plan. They effectively bought the data required to cancel a 2 million baht project before it could fail in the real world. This brings us to what business diagnosticians call the Shindanshi lens, a tool to examine your own company's culture. Are you actually ready for innovation? Ask yourself, when a project falls apart, what is the very first thing your leadership does? Do they immediately start hunting for a culprit to blame, or do they call a meeting to hunt for the lesson? And when you realize an idea isn't working, do you have courage to cut your losses? Or do you fall into the sunk cost trap, blindly funding a doomed project for another year just because you've already spent so much time on it? This requires completely reframing how you view trial and error. Think about Thomas Edison working on the incandescent light bulb. He systematically crossed 10,000 materials off his list. Each rejected filament provided data points to narrow his search until only the working solution remained. Intelligent failure scientifically eliminates the wrong paths, which accelerates your journey to the right one. But that leaves us with one final, very difficult question. When your experiments keep hitting a wall over and over, How do you know if you should stubbornly persevere or if it's finally time to pivot?